This topic is most important, students, because these four forces, they are just what? Controlling our nature. They have a direct impact on us. That's why we must know what are these forces, types of forces. We will get to know all the different varieties of forces in different chapters, but we must know at the beginning. See, clear? So the four basic type of forces in nature, they are: first one, gravitational force. Gravitational force. The second one is electromagnetic force. Third one is strong force, and the fourth one is weak force. Clear? We know actually these are four fundamental forces of nature. There are other forces, but they are not fundamental. Yes, if you try to analyze the other type of forces, the origin might be out of these three. This may be the origin of most of the forces. Clear? Now, these are the fundamental forces. There are so many upcoming theories are there. Theories are coming up to club together all these forces and to have a grand unification theory where the root of all the forces will be only one force. Research is still going on. Clear? In behind that grand unification theory. So let me explain you the nature of all these forces individually. First one is your gravitational force. This is a variety of force, or you can say these are not forces, they are interactions, we can say. Four basic interactions. Gravitational forces, they exist between bodies having masses. However small it may be, if a body is having masses, it can interact with other bodies having masses. And that interaction is called your gravitational interaction. We will deal this force in detail. There is a chapter called gravitation. Clear? So only you remember gravitational force is a variety of force that exists between objects having masses. Now comes to your electromagnetic force. This is the most important force in relation to us. Every process in our bodily mechanism, it is governed by these electromagnetic forces. Clear? And this force exists between charged particles. What is charged particle? There are also some fundamental properties of natures, intrinsic properties of natures or objects. If, just like your gravitational forces is what? If two objects, they have mass, then they can interact, and that interaction leads to your gravitational interaction. If the two objects, they have charge, it's another kind of property of a body, other than mass, it's another property of a body. If any objects having charges, they can interact, they can talk to each other, and that interaction is called your electromagnetic interaction. Clear? And these two strong and weak forces, they are actually strong and weak nuclear forces. They are dealing with the forces that exist within the nucleus. Let me explain you. Actually, this nucleus concept is already known to you because in your standard 10th, suppose you just a very simple atomic structure. Atom is what? Spherical in nature. Let's very smallest, very root example, you take hydrogen atom. Hydrogen atom is spherical in nature. The central part, this central part of an atom is called your nucleus. This part is called your nucleus, and electrons revolve around in some circular orbits. This is the present atomic structure we are following. So see, your within this nucleus, this force, these two forces, they have their importance, and outside this force is most important. Clear? And again, outside this world, in the macroscopic world, these gravitational forces are very important, because in dealing with your galaxies, and our solar system and your stars, planets, these forces is of importance. And electromagnetic force, it is within your atoms, molecules, and like that. And this strong and weak nuclear forces, they have their influence within this nucleus. And see, this strong nuclear force, actually these two are nuclear forces, and strong nuclear forces is responsible for binding the protons and neutrons within this small space. Clear? See, these two, they will be taught in your 12th class. That is, there is a topic, nuclei. In that topic, you are going to learn what is these two forces. And dear students, this is also helpful for you while dealing with the physics, while dealing with some calculations, because these prefixes we are going to use before some of the units. While dealing with some other units, we uses this prefixes. Like this part, I have made it to different parts. These other units are there. So the prefixes are like this: deci, centi, milli, micro, nano, pico, femto, atto. See, to remember this, there's a technique actually. It's a -1. So remember easily: -1, -2, -3, and after -3 is coming -6. Then 3 difference: -6, -9, -12, -15, -18, like that. So these prefixes are divided in such a way. So this is -1. So as you are observing here, similarly it is -1 means 1/10 you can say. Here 1/10, 1/100, 1/1000. Just like that. Here deca is 10 to the power 1. There it is negative, and here it is positive value. The same value here, the powers are positive. 10 to the power 1 is your deca, hecta is 10 to the power 2, kilo is 10 to the power 3, mega is 10 to the power 6, ziga is 10 to the power 9, tera is 10 to the power 12, pecta is 10 to the power 15, hexa is 10 to the power 18. Then how these prefixes are being used? Like suppose somewhere it is written in your book, the distance of separation between two masses, it is 1 nm. 1 nm. N stands for here, the symbol for nano is small n. Micro means you can write mu. Milli, small m. Centi means small c. Deci means small d. And pico means here small p. Femto means f, small f. Atto means small a. So this symbol, this small symbol, this symbols, they signifies the value of the power of your 10. Like here n for nano, and the order of magnitude here is 10 to the power -9. Here you multiply here, 1 nanometer means 10 to the power -9 meter. Clear? Similarly, 1 gigasecond. Giga, it's capital G, capital M, K, it is H, it is D, or sometimes it is DA, it is capital T, it is capital P, it is capital E. So you can see, if somewhere it is written, it is 1 gsec. Gsec means gigasecond. 1 giga is how much? Giga is 10 to the power 9. So 10 to the power 9 second. Or somewhere you will find like this. Let's say 1 m, small m into a. Your small m, you see, small m stands for milli. So a is the unit of your current, that is electric current ampere. So its value is 1 milliampere. So in this way you are going to use these metric prefixes. So it is most important so that you can remember these metric prefixes.